Hello, and welcome to section 1. Deep learning is a part of machine learning that deals with training large neural networks to solve complex input-output transformations. For example, to map a selfie to the name of the person on it, just like social networks do, or to describe a picture with a phrase, which is another more recent application of deep learning. In this section, we are going to take a look at what is deep learning, which open source libraries for deep learning are the most popular, and finally, we will go through a deep learning hello world example. So let's start with what is deep learning. In this video, we will look at neural networks, the real power behind deep learning. Also, when should we turn to deep learning? To talk about deep learning is to talk about neural networks, which are functions that transforms inputs X into outputs Z, and they don't do so in just one or two steps, in which case we would call them shallow neural networks. Instead, they transform the data sequentially using several intermediate operations, which are also called layers. In this graph, we represent the hidden layers in green. They are all based on similar operations, which are usually just multiplications and summations, followed by a nonlinearity, such as the hyperbolic tangent, or the rectified linear unity. What changes from layer to layer are the different parameters W and V, which are called weights or synapses of the neural network. The best use case of deep learning is the supervised learning problem, where we have a large data set of inputs associated with desired outputs. For example, a large data set of images of cats and dogs, each one mapped either to 1, 0, which we assume means cat, or 0, 1 to mean dog. In this case, we can use the backpropagation algorithm to minimize the chances of the network making wrong classifications, such as these ones in this slide, where the dog has been classified as a cat. There are other problems that are not well modeled as supervised learning, though, to which we can still apply deep learning, like unsupervised or reinforcement learning problems. But even those can benefit from the strategies used for supervised learning that we will cover in this course. In conclusion, the best case scenario to deep learn is when we have hundreds of thousands of input-output pairs. Depending on how general the problem is, we may even need millions of such pairs. Thankfully, there are very good open source and large datasets out there that we can use to train practical neural networks. Here I show a few examples. One of the datasets that deep learning gives state-of-the-art results is the terabyte-scale ImageNet dataset of pictures that should be classified into one of 1,000 of different classes, such as cats, dogs, bike, train, between many others. Also, if you have a smartphone and make speech queries to OK Google or Siri, you are actually talking to a neural network that transcribes your voice. In this video, we learned that neural networks are the main mathematical models behind deep learning, and what is the best case where deep learning can usually give us good results. In the next video, we will cover some of the open source libraries for deep learning.